This video will use a Prony brake and the sweep feature of VESC Tool to show that the torque that a motor produces is proportional to the phase current. Motor theory tells us that we can use the kV rating of a motor to get the torque-current relationship in Newton meters per amp, but we need to make some adjustments for a three-phase motor. The FlipSky 6368 motor I'm using has a line-to-line kV of 190 RPM per volt, so for every volt applied to the motor adds 190 RPM to its speed. We start the conversion by flipping the units of the kV since faster motors with higher kV have lower torque per amp. We then convert from revolutions per minute to radians per second. We change the line-to-line voltage to a line-to-neutral voltage by dividing by the square root of 3. To count the torque from all three phases, we multiply by 3. Since we're measuring peak current, we divide by 2 to get the average torque. Our number is in volt-seconds per radian. We notice that a volt is a joule per coulomb, that a joule is a newton meter of torque rotated by a radian, and an amp is a coulomb per second, and we get newton meters per amp. For this motor, for every amp of phase current, we get about 0.04 newton meters of torque. Let's see if we can measure this value. One way to measure torque on a spinning motor is by using a Prony brake. This Prony brake uses felt and a tension screw to provide adjustable friction and a lever arm to push down on a kitchen scale to read the force. We can take the scale reading in grams, convert to kilograms, and multiply by gravity to get the force in newtons. Then we can take the force on the scale in newtons and multiply by the length of the arm to get the torque of the motor. We use the Experiments tab of VESC Tool to raise the current in 1 amp steps from 10 amps to 15 amps. We see the red line increasing by 1 amp every 5 seconds. The inset video shows the reading on the scale increasing about 30 grams for each 1 amp step. We can plot these readings with current on the x-axis and torque on the y-axis. When we fit a line to these data points, we see the slope of the line is 0.0413 newton meters per amp. This value matches our prediction of 0.0435 newton meters per amp to within about 5%. So one takeaway is that the motor torque is proportional to the phase current, and this can be calculated from the motor kV. The other takeaway is that a higher kV motor generates less torque per amp.